Okay, in this presentation we are going to look at sampling. So here we are picking beads from an urn, okay, and let's just read the question here. So let's go on to the next slide there. Suppose an urn contains 7 white, 4 black and 3 red beads. 3 beads are picked at random without replacement. Now watch that without replacement question here, because is that important? It could be. But let's read the questions first, because probably in this instance it's not hugely important in this particular instance. Find the probability that all 3 beads are of different colours, and B, at least 2 beads are the same colour. So that's question A and question B. So in this case, we'll look at question A first, because the fact that of it being with or without replacement is not hugely important there. So, sampling from an urn. So, probability that all 3 beads are of different colours. So, what we have to do is find out how many ways we can pick out 3 beads out of 14. So, from 14, choose 3. So, here, using the binomial coefficient formula, n is 14, so we have n factorial. K is 3, so we have 3 factorial, and n minus k is 14 minus 3, which is 11 factorial. When we divide 14 factorial by 11 factorial, we get 14 times 13 times 12, and 11 factorial cancels out. And we have 3 times 2 times 1 on the bottom of the fraction. Working that out, we will get 14 times 13 times 12 divided by 3 times 2 times 1. That is 364. So there's 364 ways to pick 3 beads out of 14. Okay, the number of ways to pick 1 white, 1 black, and 1 red. Okay, so in this instance, the sampling without replacement issue is not particularly relevant in this question, but just watch out for it, because it might, in other more elaborate questions where the question is longer, it might be relevant. Which is to say, I've knocked out a question where it would have been relevant. Anyway, number of ways to pick 1 white, 1 black, and 1 red. So we have 7 white beads, so there's 7 ways we can pick out a white bead. 4 black beads, so 4 ways, and 3 red beads, so we have 3. 7 times 4 times 3 is 84. So the probability that all 3 beads are different is 84 divided by 364, which is approximately 23%, 0.2308. Okay. Now, the probability that at least 2 beads are different colour. At least 2 beads are different colour. That's important, because essentially that is the complement of what we have found previously. Okay. In the previous example, I'll just go back to it. They all have different colours. This is the complement of that. Okay. That's really all we have to do here. So just sort of think about the question. These probability questions become very simple once you develop that intuition. Okay, so the probability of at least 2 beads being the same is 1 minus the probability that all 3 beads are different, and that is the complement of what we found previously, 1 minus 0.2308, and that gives us 0.7692, 76.92%, essentially nearly 77%. Okay, so that's it. Let's just go back there. I think I've covered everything there, yeah. So essentially the importance there is just actually reading the question properly. And watch out for these red herrings, because essentially the without replacement here, that component there was not really relevant. Okay, but I deliberately kept it in. Okay, bye bye.